NCERT and Cbse 10th standard for mathematics and science. So in this session we will be going with the very important concept of quadratic equations, that is nature of the roots of quadratic equation. So nature in the sense, the roots of a particular quadratic equation is not same for all quadratic equations. The roots of the quadratic equation depends on particular factor, on a particular thing, on a particular factor it depends. So in this session we are going to learn how the nature of the roots of a quadratic equation depends upon the coefficients of the quadratic equation. That is, the nature of the roots of the quadratic equation depends upon the coefficients of x square, coefficient of x and the real constant. That is, it depends on a, b and c. The values of a, b and c for a given quadratic equation defines the nature of the roots. Right? So here, as we solved some four particular problems on quadratic formula in the previous session, we came across four different types of roots. So in the first quadratic formula, that is problem, we came across two roots which were both rational. So both were real and rational. So in the second problem we come across two roots where the nature of the roots were totally complex. That is, under the square root sign we had some negative number. So those numbers are called as complex numbers, or the value of those numbers is said to be totally imaginary. So they are not real numbers. They cannot be called as real numbers. They do not come under the category of rational numbers or irrational numbers. So they are neither rational nor irrational. So therefore there will be a separate category of numbers called as real numbers. So apart from that, in the third problem we came across two roots which were irrational. That is, we had the roots of a quadratic equation where it had the root sign but it had a positive radicand inside it. So therefore those numbers were called as irrational numbers. So we got two irrational numbers. So though if a quadratic equation gets some irrational roots, they are real numbers, because irrational numbers are also real numbers. So in the fourth problem we come across two roots of the given quadratic equation where they were both equal to each other. So in the previous session itself we have come across the different types of roots of a quadratic equation. So here in this session we are going to check out why this happens, on what factors does the nature of the root depends. So for a given quadratic equation, why we get equal roots? For a particular quadratic equation, why do we get always irrational roots? For a particular quadratic equation we do not get any real roots. Do not get any real roots in the sense there will be neither rational nor irrational. So that's the meaning of that. So for particular quadratic equations we get rational roots. So in this session we are going to see on what factors does the nature of the roots of a quadratic equation depends. Right. So you are well aware of the problems on quadratic formula. So I am going to present four problems on quadratic formula now. So in each and every problem we are going to analyze the nature of the roots and on what factor does the nature of the root depends. Right. Okay. So on board I have a quadratic equation here, x square minus 2x plus 1 is equal to 0. It's a quadratic equation, it is already in the standard form. We will apply the quadratic formula to this and find out the roots. Alright, what we have already done in the previous session. So we will do it again. So here I am going to just cut out the steps to reduce the number of steps here. So here a is equal to 1, b is equal to minus 2, c is equal to 1. So x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Okay. So x is equal to minus b, that is minus of minus 2 plus or minus square root of, right, b square, that is
minus 2 whole square.
Square minus 4 into
1 into 1
by 2 into 1. Okay. So x is equal to 2 plus or minus square root of minus 2 whole square is 4 minus 4 into 1 is 4 by 2. Okay. X is equal to 2 plus or minus 4 minus 4 is
0.
Square root of 0 by 2. So this is a very important step here. Just look at the value of b square minus 4ac. Instead of b square minus 4ac, by substituting the value of a, b and c, we have got the value as 0. Okay, you should observe that. So x is equal to 2 plus or minus 0 by 2 So therefore x is equal to 2 plus 0 by 2 is 1, or x is equal to 2 minus 0 by 2 is 1. So here we can see that the roots are equal. Both the roots are equal. Okay. So we have got 1 here, 1 here. Both are real numbers, right? And they are rational. Both are real numbers and rational, right? And apart from that, they are equal. So 3 parameters you have to observe here. One is they are real numbers, okay? They are rational numbers, they are real numbers, and they are equal. So for this particular type of quadratic equation, here the roots are x is equal to 1 and x is equal to 1, where the roots are real, rational, and equal. So here, to get these type of roots, who is responsible here? Who plays a very important role? Which part of the formula plays a very important role to get these type of roots? So here we have to look at this b square minus 4ac. So here the value of b square minus 4ac has become equal to 0. So then in a quadratic equation, if b square minus 4ac is equal to 0, then the nature of that particular type of quadratic equations, roots of that particular type of quadratic equations will be real, rational, and equal. Real, rational, and equal. So this is the conclusion, right? So when will be in a quadratic equation, when will be the roots real, rational, and equal? Or else you can directly roots are equal. Just you can announce it. Roots are equal. So when does in a quadratic equation roots will be equal? So in a quadratic equation roots will be equal if and only if b square minus 4ac is equal to 0. So here b square minus 4ac, when it becomes equal to 0. So here in the sense b square minus 4ac is going to decide what type of roots this particular quadratic equation should get. So this quadratic equation should get equal roots, and that is decided by b square minus 4ac. Therefore, for this equal roots, for this quadratic equation another type of roots, for this another type of roots. So this b square minus 4ac is going to discriminate. It is going to discriminate, right? So here your school is going to discriminate you into different classes based on your age. You are some age, you go to this class. You are 1 year older than that, okay, go to this class. 1 year older, okay, go to this class. So your school discriminates you on the basis of age to different classes. In the same manner, b square minus 4ac, if it is equal to 0, then in any quadratic equation, not only for this I am telling you, in any type of quadratic equation, if the value of b square minus 4ac in that is equal to 0, then the nature of the roots of this quadratic equation will be real and equal. Real and equal. Right? It's an example I have taken, that's all. Like this, there are n number of quadratic equations. So in all those quadratic equations, if b square minus 4ac is equal to 0, then the roots are real and equal. Right? Okay. Let us get into the second problem. Yeah.
X square minus 2x minus 3.
Okay, x square minus 2x minus 3. So, okay, this is the quadratic equation given by my student. Let us see what type of roots we are going to get for this. Right? Okay. So, a is equal to 1, b is equal to minus 2, c is equal to minus 3. Okay, we have written the coefficients. Right. Let us apply the formula. So, x is equal to minus b plus or minus square root of b square minus
4ac by 2a.
Okay. So x is equal to minus b minus of minus 2 plus or minus square root of b square
Minus 2 whole square.
minus 4 into 1 into c
minus
3 by
2 into 1.
2 into 1. So x is equal to 2 plus or minus square root of minus 2 whole square is
4.
4 minus into minus is plus.
Plus.
4 ones are 4, 4 threes are
12.
by 2. Okay. So x is equal to 2 plus or minus square root of 4 plus 12 is
16.
16 by 2. So look at this number, 16. So 16.
4 square root of.
Okay, 16 is a, you should look only the radicand which is inside the root symbol. Square root of 16 is 4, that is a different criteria, right? So inside the square root you are having 16. So speciality of 16 is it is a very good number, that is it's a perfect square, isn't it? So and moreover 16 is greater than 0. Here in this case it is equal to 0, that is b square minus 4ac is equal to 0, but in this case b square minus 4ac is greater than 0 because we have got 16 and also it is perfect square, that's an added advantage there. So it is greater than 0 and also a perfect square. So let us see if b square minus 4ac is greater than 0 and also a perfect square. Let's see what type of roots we are going to get. Right? Let us proceed with this. So x is equal to 2 plus or minus 4 by 2. Square root of 16 is
4.
Okay. So x is equal to 2 plus 4 is 6 by 2. That is 6 by 2. Or x is equal to 2 minus 4 is minus 2 by 2. So x is equal to 3 or x is equal to minus 1. X is equal to minus 1. So here you can see both the roots are real. Both the roots are real and rational. Real and rational. They are not equal. It is 3 and it is minus 1. They are not equal. But 3 by 1 is a rational number. Minus 1 by 1 is a rational number. So therefore the roots are real and rational. Right? I hope you got it. So for a particular type of quadratic equation, if you want to get real and rational roots, then the discriminant value, that is b square minus 4ac value, will be or should be greater than 0 and also it should be a perfect square. Correct? So this is the second nature of the roots. So this is the nature of the roots is decided by whom? That is b square minus 4ac. That is called discriminant. B square minus 4ac is called discriminant. Okay, this b square minus 4ac calls this quadratic equation. Hey, you come here, you get equal roots. Hey, you come here, you get this type of roots. So this discriminates. Right? So here, as b square minus 4ac is equal to 0, therefore we have got real and equal roots. Real and equal roots. If b square minus 4ac is a perfect, is greater than 0 and a perfect square, then the roots are real and rational. Why I call real? Because it is rational numbers. Rational numbers are real numbers. So real and rational. Done? Okay. Along with this I can use another particular word. So the roots are real, rational and distinct. Distinct in the sense this is separate, that is separate, this is different, that is different. Both are not same. Both are not same. So that's the meaning of the word distinct. They are distinct. It is different. This is different. It is no way concerned with this. When we want to express these things, we use that particular word. That is, they are distinct. Right? So here the roots are real, rational, and distinct. Right? Okay. Let us get into the third example. Okay. Tell me one more quadratic equation.
X square minus 2x plus
X square minus 2x
plus 3.
is equal to 0. Okay. Oh, okay. Here we have minus and we have there plus. Okay, right. So A is equal to 1, B is equal to minus 2, C is equal to 3. Okay. So X is equal to minus B plus or minus square root of B square minus
4ac by 2a.
Okay. So X is equal to minus B
Minus 2 minus 2.
plus or minus square root of B square
Minus 2 whole square.
minus 4 into A
1.
C.
3.
Okay, very good. By 2A, 2 into
1.
okay. So X is equal to minus into minus 2 is
2.
2 plus or minus square root of 2 wholes minus 2 whole square is
4.
4 ones are 4, 4 threes are 12. That is
Minus
minus
12.
12 by 2.
2.
Okay, X is equal to 2 plus or minus square root of 4 minus 12.
Minus 8.
Minus 8 by 2. Okay, right. X is equal to 2 plus or minus. This can be written as 4 into
Minus 2.
4 into minus 2 because it is minus 8. So by 2. So X is equal to when 4 square root of 4 into square root of minus 2 happens. So square root of 4 is 2. So 2 plus or minus 2 root minus 2 by 2. Right? So square root of 4 is 2 and square root remains for minus 2 I have written it. Okay, here we can take 2 as common. So when we take 2 as common here, we get x is equal to 2 into 1 plus or minus square root of minus 2 by 2. So 2 and 2 cancel. So x is equal to 1 plus or minus root minus 2. 1 plus or minus square root of minus 2. So here, if you observe this, we have two roots. X is equal to 1 plus square root of minus 2 and x is equal to 1 minus square root of minus 2. But inside square root we have a negative number, right? So in the second problem, in yesterday's session, in the second problem, we came across the same thing, right? So here, in this case, the roots are said to be imaginary and complex. It's not the meaning, imaginary or complex. The roots are imaginary, the value of that is complex, right? So let us see the value of discriminant here. So b square minus 4ac is here. The value of that is minus 8. What is minus 8 on the number line? It is less than 0. Minus 8 is less than 0. And less than 0, that's all. Being a perfect square, being not a perfect square doesn't count. So value b square minus 4ac value is less than 0. So for any particular type of quadratic equation, if you get the value of the discriminant less than 0, then the roots of those type of quadratic equations will be complex or imaginary, in the sense they are not real roots. What the meaning? They are not real roots. These are all not real roots because they are not real numbers, right? Okay, once again we will recap. If b square minus 4ac is equal to 0, then the roots are real and equal. Real, rational and equal. Okay, anyway. So if b square minus 4ac is greater than 0 and a perfect square, then the roots are real, rational and distinct. Real, rational and distinct. They are real numbers. Both are different, therefore they are distinct, right? And they are rational, in the sense 3 by 1 minus 1 by 1, they are rational. They are real numbers because rational numbers are also real numbers. So real, rational and distinct. So in this case, b square minus 4ac is less than 0. Therefore the roots are complex or imaginary. Sir, I don't want to tell that complex or imaginary. So then say that they are not real roots. That's all, right? Okay. Okay, let us get into the fourth quadratic equation, right? So, yes.
X square minus 8x
X square minus 8x minus 7
is equal to.
Okay, so we have another type of quadratic equation. In this we are going to get another different type of nature of the roots. Let's see. Right. So when compared with standard form, we get a is equal to 1, b is equal to
minus 8,
c is equal to
minus 7.
Okay, right. So let us write the formula. So x is equal to minus b plus or minus square root of b square minus
4ac by 2a.
Okay. So x is equal to minus b, that is minus of
Minus 8.
a plus or minus square root of b square.
Minus 8 whole
B
square.
square minus 4 into a
1.
into c
Minus 7.
minus 7 by 2 into a 2
2 into 1.
into 1. Okay, 2 into 1. Right. So x is equal to minus into minus 8 is 8 plus or minus square root of minus 8 whole square is
64.
minus into minus is
Plus
4 ones are 4, 4 sevens are
28.
28 by 2 into 1 is
2.
right. So x is equal to 8 plus or minus square root of 64 plus 28
92.
90.
2.
Okay, by 2. So x is equal to 8 plus or minus, you have to split 92 into two numbers as a product of two numbers such that one of the numbers should be a perfect square. Yesterday's session we have discussed these things. So what number comes for 92?
23 4.
23 into 4. Okay, beautiful. So 92 can be written as 23 into 4 by 2. Okay, nothing but you have to take LCM for this. Take LCM for 92. take a combination of perfect square and multiply all the remaining terms to get another number. That's all. So 23 into 4. So square root of 23 into square root of 4 becomes, so square root of 4 is 2. So x is equal to 8 plus or minus 2 root 23 by 4. Okay, no problem.
2.
Oh, sorry, 2. So I was thinking that 2 1 side to 4 side goes. I was thinking. So therefore I wrote 4. Right. So x is equal to 8 plus or minus plus. Let us take 2 as common in the numerator. So 2 into 4 plus root plus or minus root 23 by 2. So 2 and 2 gets cancelled. So x is equal to 4 plus or minus root 23. So this can be written as x is equal to 4 plus root 23 or x is equal to 4 minus
root 23.
So you can see an irrational number here. In this case you can see an irrational number. So the sum of a rational and an irrational number is an irrational number. Remember this. The difference of a rational and an irrational number is an irrational number. So therefore these two are irrational roots. So the roots are real and irrational. Right? Can I announce this? As these two roots are irrational numbers. Irrational numbers are real numbers. So therefore the roots are real and
Irrational.
So let us look at the value of discriminant here. B square minus 4ac is the discriminant. Its value is 92. Right. So what is 92? 92 is a number which is greater than 0 but not a perfect square. Yes, that's the meaning, right? So the value of discriminant b square minus 4ac is greater than 0 but not a
Perfect square.
For such type of quadratic equations, we are going to get real and irrational roots, right? So overall taken, these are real roots and these are real roots and these are real roots. So which are not real roots? So when b square minus 4ac is less than 0, then the roots what we get are not real. So only there are 4 types of nature of the roots: real and equal, real and rational, real and irrational, and complex or imaginary. 4 types. These 4 types can be modified and done into 2 types. One is real roots and non-real roots. Two categories. In real roots we have 3. One is roots are real and equal, roots are real and rational, roots are real and irrational. These 3 comes under real roots. Those roots which are not real are when b square minus 4ac is less than 0. So in all the 3 cases we can see b square minus 4ac is equal to 0 or greater than 0. So in this case only we can see that b square minus 4ac is less than 0. So from this we can come to 2 very important conclusions or 4 important conclusions. Anything you can take. First I will tell you 4 conclusions. If b square minus 4ac is equal to 0, right, keep it in your mind. If b square minus 4ac is equal to 0, then the roots are real and equal. Right? If discriminant is greater than 0 and a perfect square, then the roots are real and rational. If the discriminant value is greater than 0 and not a perfect square, then the roots are real and irrational. Right? And if the discriminant value is less than 0, then the roots are complex or imaginary, or they are not real roots. Okay? So these are the 4 categories. Sir, no, I want just 2 categories. Very simple. If discriminant is less than 0, then the quadratic equation do not have any real roots. If the discriminant is greater than 0, then we get real roots. Done? Equal to 0 or greater than 0, we get real roots. If it is less than 0, we do not get real roots. So this is called the concept of nature of the roots of a quadratic equation. Right. So here b square minus 4ac, what we were speaking until now. Okay. B square minus 4AC. This is called discriminant. This is called as discriminant and indicated by the symbol delta, a small triangle. Small triangle in mathematics, symbol of triangle is called as discriminant. Right, so discriminant is equal to b square minus 4ac. So when you see this symbol, you can use the word discriminant. Discriminant is equal to b square minus 4ac. Done? Right. Okay, let us get into the note, very important, which will be for 1 mark in your examination. Right. Note number 1. If discriminant is equal to 0, discriminant is equal to 0, that is b square minus 4ac is equal to 0, then roots are real and equal. Real and equal. Second one, if discriminant is equal to b square minus 4ac is greater than 0 and a perfect square, then roots are real and rational. Real and rational. Okay. Third one, if discriminant is equal to b square minus 4ac is greater than 0 and not a perfect square, then roots are real and irrational. So 4 point, if discriminant is, that is b square minus 4ac is less than 0, then roots are complex or imaginary. Or in this, instead of this, they do not have real roots. Right. So here in this case, all these cases have real roots. That is, if discriminant is equal to 0, discriminant is greater than 0 and a perfect square, discriminant is greater than 0 and not a perfect square, then all the type of roots what we get, they are real roots. But if discriminant is less than 0, the roots are complex or imaginary. In a sense, we can also use the word they do not have real roots. Right. Very important. This will be for 1 mark. Okay, let us get into the very simple problems on nature of roots of quadratic equation. So find the nature of the roots of quadratic equation. So I have written the short form here. If real roots exist, so when you find the nature of the roots, and if you find that the real roots exist, then find the roots. If not, it's not required. Right? Let us see. So here, before entering into the problem, we will once again recapitulate. The discriminant of the quadratic equation decides the nature of the roots. So in order to write the discriminant, that is b square minus 4ac, we need the value of b, value of a and value of c. So this should be the values of a, b and c can be extracted from the given quadratic equation by comparing it with the standard form. Right? Okay. So 2x square minus 3x plus 5 is equal to 0. So comparing with ax square plus bx plus c is equal to 0. A is equal to ax square when compared with 2x square, a is 2. Okay. B is equal to minus 3 and c is equal to 5. Okay. We have the values of a, b and c. Right. So discriminant is given by delta is equal to b square minus 4ac, right? So delta is equal to b square, that is
Minus 3 whole square.
minus 4 into a is
2.
into c is
5.
right. So discriminant is equal to minus 3 whole square is
9.
minus 4 2s are 8, 8 5s are
40.
so discriminant is equal to 9 minus 40 is
Minus 31.
minus
31.
Oh my god, right? So discriminant value we have got it as minus 30. So discriminant is less than 0. So that is b square minus 4ac is less than 0. So this is your knowledge. Right? So b square minus 4ac is less than 0. So if the discriminant value of a quadratic equation is less than 0, then what is your conclusion? The roots are complex or imaginary, or in other words we can also write it as the quadratic equation do not have real roots. That's all, according to your textbook, right? Therefore, the given quadratic equation do not have real roots. So now as they do not have real roots, so there is no need to find out the roots, right? Okay, let us get into the second problem. For the same question, find the nature of the roots of the quadratic equation, and if real roots exist, we have to find them. If the real root do not exist, no need to find them, as we have seen in the last problem. So here we need the values of a, b and c to determine the nature of the roots, where we have to put up for the discriminant. So comparing with 4 root 3x plus 4 is equal to 0. So let us compare with the standard form, that is comparing with ax square plus bx plus c is equal to 0. So a is equal to, so ax square compared to 3x square, a stands for 3, and bx is equal to minus 4 root 3x. So b is equal to minus 4 root 3. Be very careful, minus 4 root 3. Then c is equal to 4, right? So here we have to determine the nature of the roots. So discriminant is given by delta is equal to b square minus 4ac. So delta is equal to b square minus 4 root 3 whole square minus 4 root 3
Whole square.
minus 4 into a 3 c
4.
Okay, so delta is equal to minus 4 root 3 whole square, where the square applies for minus 4 and square applies for 3 also. So minus 4 whole square is 16 into root 3 and square is there, so square and root 3, that is root symbol cancels. So 3 minus 4 3s are 12, 12 4s are 12 4s are it is, sorry, 12 4s are it is 48, okay, sorry, 48, 16 3s are 48 minus 48. So discriminant is
0.
Very good. So discriminant is 0. So therefore b square minus 4ac is equal to 0. So if b square minus 4ac is equal to 0, then we say that the roots are
Real and
equal.
equal.
Real and
Equal.
So as we have got real roots here, so therefore we will find out the roots. Right. So since b square minus 4ac is equal to 0, so therefore the roots are real and equal. You can write, no problem. Real and equal. So let us try to find out the roots. So therefore the roots are x is equal to minus b plus or minus square root of b square minus
minus
4ac
by 2a.
okay. So x is equal to, I will change the format now. So minus b plus or minus square root of d by 2a. So what is this d? Discriminant. D is
Discriminant.
that's all. So instead of delta, you can also write d. Right? In the older version of textbooks, it was given as delta. In the new textbook, it is given as d. You can use whatever you want, right? Whichever you want. So x is equal to minus b. So minus of b value
Minus
4
root
root 3.
3.
Minus 4 root.
3.
So we have minus here. Minus 4 root 3 plus or minus square root of discriminant value.
0.
Discriminant value we have got it as
0.
That's all, very simple. 0 by 2a. So 2 into
3.
a is 3. Okay, 3. I hope you got understood these steps. Very important. So x is equal to minus into minus plus 4 root 3 plus square plus or minus square root of 0 is
0.
0 by 2 3s are
6.
okay. So x is equal to 4 plus or 4 root 3 plus 0 by 6, or x is equal to 4 root 3 minus 0 by 6, right? So x is equal to 4 root 3 by 6, or x is equal to 4 root 3 by 6. So 2 2s are 2 3s are you can cancel, 2 2s are 2 3s are you can cancel. You cannot cancel 3 and 3 because it is square root of 3 and this is just 3.
3.
It's an irrational number and it's a rational.
Rational.
Okay. So x is equal to 2 root 3 by 3 is one of the root, or x is equal to 2 root 3 by 3 is another root. So why we have got equal roots here? Because discriminant is equal to 0. So both are real and equal. Real and equal. Right. So give me another problem.
2x square
So please do it as a homework. 2x square
minus 6x
minus 6x
plus 3.
plus 3 is equal to 0. So this is the third quadratic equation. For this also you have to find the nature of the roots of the quadratic equation, and if the real roots exist, then you have to find them. Right? So until now I hope you enjoyed the entire session here. All the two problems including the concept of nature of the roots was very important. So in tomorrow's class also we are going with still more very important problems on discriminant of a quadratic equation. So until then, stay home, stay safe and keep learning. Thank you.